theorem, every convergent sequence has unique limit. Every convergent sequence has unique limit, or in other words, if limit exists then it is unique. In other words, if limit of sequence exists, then it is unique. So now we are going to prove about theorem by using contradiction, that is prove by using contradiction. Suppose limit n tends to infinity. Suppose xn is the given sequence and xn has limit say L1, and limit n tends to infinity, xn is equal to L2 with L1 is not equal to L2. So now since L1 is not equal to L2 implies mod of L1 minus L2 is always greater than or equal to 0. Since we know that 2 is not equal to 5, so the mod of 2 minus 5 is equal to mod of minus 3, which is equal to 3, and therefore L1 minus L2 is always greater than or equal to 0. So if we take epsilon is equal to L1 minus L2 divided by 2, which is greater than 0, for this epsilon there exists a positive integer m1 such that xn minus L1, there exists positive integer m1 such that xn minus L1 is less than epsilon for every n greater than or equal to m1. This is our definition of limit. Similarly, there exists a positive integer m2 such that xn minus L2 is less than epsilon for every n greater than or equal to m2 by using definition of limit. Since what is given, the xn has limit L1 and xn has limit L2, means what, if we take any epsilon greater than 0, there exists positive integer m. So for this epsilon greater than 0, there exists m1 such that xn minus L1 less than epsilon, and m2 such that xn minus L2 less than epsilon for every n greater than m1 and n greater than or equal to m2. So if we select m is equal to maximum of m1 m2, then this two equation are true. Both the equation inequality are true for m. Okay, both the inequality true for m. So if we select m is equal to maximum of m1 m2, now consider L1 minus L2, which is equal to, we can write this as L1 minus xn plus xn minus L2. So we add and subtract xn. So this is equal to, now by using triangle inequality, we know that since mod of a plus b is less than or equal to mod of a plus mod of b, by using this we can write this as, if we consider this as a and this as b, then L1 minus L2 less than or is equal to L1 minus xn plus xn minus L2. Now since L1 since minus mod a, which is same as, or a minus b, say here mod of a minus b is same as mod of b minus a. By using this property, we can write this as it is less than or equal to xn minus L1 plus xn minus L2. So here xn minus L1 is equal to xn minus L1 is less than epsilon and xn minus L2 is less than epsilon if we select which is less than epsilon. Okay, less than epsilon plus epsilon if n is greater than or equal to m. For this m, both the inequalities are true. So but which this implies L1 minus L2 is less than 2 epsilon. So what is the epsilon here? The value of epsilon is equal to L1 mod of L1 minus L2 divided by 2. So if we put the value of epsilon here, then mod of L1 minus L2 less than 2 times, okay, mod of L1 minus L2 divided by 2. So this 2 will get cancelled here, and mod of L1 minus L2 less than mod of L1 minus L2. So here we get some contradiction, which is contradiction that L1, what is the contradiction here? Mod of L1 minus L2 is less than mod of L1 minus L2. This is never true. We know that 2 is not less than 2. 2 is always less than or equal to what? 2. So we obtain this contradiction because we assume here, we assume L1 is not equal to L2, and therefore since we obtain contradiction from this, we can say that L1 is equal to L2. That is, if the convergent sequence, from this we can say that a convergent sequence has unique limit. From this we can say that convergent sequence has unique limit. We can use this theorem for to prove the given sequence is divergent. That is divergent. We know that if P implies Q is same as, which is equivalent to negation of Q implies negation of P. That is if the limit is not unique, then the given sequence xn is divergent sequence. For example, this is the first divergent criteria, or you can use this theorem to prove the given sequence is what? Divergent. For example, if we take the sequence xn is equal to minus 1 raised to n for every n, for every natural number n, then limit n tends to infinity, xn is equal to, it has two limit point 1 and minus 1. Okay, and therefore the limit is not unique. Since limit is not unique, we can say that here the sequence xn, which is equal to minus 1 raised to n, is a divergent sequence. Is what? Divergent sequence. If we take one more example here, xn is equal to minus 1 raised to n into n divided by n plus 1. Again, if we take here limit n tends to infinity, then of xn is equal to limit n tends to infinity minus 1 raised to n divided by n minus 1 raised to n into n divided by n plus 1 is equal to limit n tends to infinity minus 1 raised to n 1 divided by 1 plus 1 by n, that is we divide numerator and denominator by n, then this is equal to again the value of this limit is equal to 1 and minus 1. That is, this sequence has two limit point. Again, we know that as n tends to infinity, the value of this term is equal to 0, and therefore the value of this limit, this sequence has two limit 1 and minus 1 as n tends to infinity, and therefore the given sequence xn is divergent by using this theorem, above theorem. What the above theorem says? If the limit is not unique, then xn is, the given sequence xn is what? Divergent. Thank you.